Okay, let's look at part B of example 4. We're going to graph the function y equals 2 secant x over 3 plus pi over 2 plus 2. Okay, so I'm going to write this in standard form before we do anything, which means I need to factor 1/3 out of this. Okay, when I factor 1/3, I'm taking pi over 2 and dividing it by 1/3, right? So that's pi over 2 times 3 over 1, so that's 3 pi over 2. Okay, here's my A, here's my B, here's my H, here is my K. Okay, but we are going to graph the cosine function first, and then use that to graph our secant function. Okay, so our amplitude is 2, okay, even though the amplitude, or secant function doesn't have an amplitude, but cosine does. My period is 2 pi over b, which is 2 pi times 3 over 1, or 3. So my period, okay, is 6 pi. I do have a phase shift here, right? I'm going left 3 pi over 2 units, and I have a vertical translation. I'm going up 2 units. Okay, so I am going to start, right? I'm shifting left 3 pi over 2 units, so instead of starting at 0, I'm going to shift to negative 3 pi over 2. And to figure out where I'm going to end that first pi, or that first period, I'm going to take my period and shift that over 3 pi over 2 units. Okay, so if I get common denominators here, that would be 12 pi over 2 minus 3 pi over 2 is 9 pi over 2. So there's my start, and there's my end of the first period. Okay, so it's ending at 9 pi over 2, and it is starting at negative 3 pi over 2. Okay, I am going to go ahead and find those critical points to figure out the distance, right, between critical points. I take my period and divide by 4. Okay, so the distance between all of my critical points is 3 pi over 2. Okay, so I am starting at negative 3 pi over 2. So to get to my next critical point, I add 3 pi over 2, which is 0. Okay, so that's also where my vertical axis is going to go. To find my next critical point, I'm going to add 3 pi over 2. Okay, to find my next critical point, I'm going to add 3 pi over 2 once again. Okay, and that reduces to 3 pi. Just to double check my math here, I'm going to take 3 pi over 2, which I can write as 6 pi over 2, and add 3 pi over 2, and I get 9 pi over 2, which is what I should do. Okay, now I'm going the other way, right? So negative 3 pi over 2 minus 3 pi over 2 is negative 6 pi over 2, which is negative 3 pi. Okay, and I'm not going to calculate the rest of these out. I'm just going to fill them in. Okay, that would be negative 9 pi over 2. This is going to be negative 6 pi, and this is going to be negative 15 pi over 2. Okay, I have an amplitude of 2, however, I do have a vertical translation of 2 as well. Okay, that means my midline, right, I'll draw it in green, I guess, moves up to y equals 2. Okay, so I'm going to start by graphing this cosine function. Okay, with cosine, I start at my max. My max is 2 units above the midline. Okay, and I'm starting at my phase shift, which is negative 3 pi over 2. Then I go to my midline, okay, down to my min, back to my midline, and up to my max. And remember, my min is 2 units below the midline. Okay, here I'm at my max. I go to my midline. 2 units below is my min. Back to my midline. 2 units above is my maximum. Okay, so here is that cosine function. Okay, now I'm going to use the cosine function to graph the secant function. Okay, anywhere that function crosses the midline, I've got a vertical asymptote. Okay, anywhere that function crosses the midline, I've got a vertical asymptote. And then from there, I can fill in my cosecant, or I'm sorry, my secant function. And it looks like that. Okay, if I'm looking for my asymptotes here, they are vertical lines, so they have the equation x equals, so x equals negative 6 pi, negative 3 pi, 0, and